Welcome to the project demonstration of battery management system along with SOC and SOH calculations. So the main application of this project is when we are utilizing the AVs, means electrical vehicles. There the major part of the vehicle is motor and the battery. And the battery is a very secure device. We need to monitor the device parameters like voltage, current, along with the temperature, as well as SOC and SOH. SOC, SOH for monitoring the health status of the battery pack, and voltage and current for battery levels monitoring, and temperature is for the safety of the EV. And for the temperature purpose, we are utilizing this temperature sensor, and battery we are using 12 volt 1 amp battery pack, which is consist of 3 4 volt 1 amp batteries are connected in series. So this one is representing as a EV battery pack, and which is continuously monitored by our microcontroller, which is do the operation of battery management system. There is a BMS by continuously monitoring the voltage levels of this battery pack using this voltage sensor, and the voltage data will be displayed on the LCD screen. And whenever the battery voltage is less than the threshold value, means whenever the battery voltage is less than 9 volts, then the microcontroller will on this electromagnetic relay to make the battery under charging purpose. And whenever the battery voltage is above 13.5 volts, then that is indication of battery is fully charged. Then the system will off this relay to protect the battery from overcharging. And whenever the low battery or high temperature battery pack temperature increased, then this battery the system will on this buzzer to provide the audible alert. And here one more feature is like SOC SOH calculations. SOC nothing but state of charging. Whenever we are charging a battery, this system consists of the ratings of the charging current, means 1 amp current of charger current we are providing, and this one is a 12 volt 1 amp battery. And when we on this relay, the particular voltage of charger voltage along with the respective current will be given as input to the battery pack for charging purpose. And when this charging has to be increased according to the current rating, and if it is not increased, means it's not charging according to the current input, then the system continuously measuring the voltage differences for every certain time duration. That is a Coulomb counting method. So if it is not reaches the certain voltages in certain time, then the SOC value will be decreased from 100% to 90, 80, 70 based on the voltage difference based on this current voltage input. And at the same time, that is for the SOC calculations. SOH nothing but whenever the battery voltage decreases rapidly, then the SOH value also will be decreased rapidly from 100 to 90, like that. Means charging purpose we are going in the charging of the battery pack, we are calculating SOC values, and discharging, when the battery is discharging, then the SOH values will be calculated. And during this charging and discharging, either from the relay or normal load, then if any battery pack temperature increased, then the system will provide us the audible alert through the buzzer. And for these features, main components we are using is thermistor, this temperature sensor, and 12 1 amp battery pack, and a 16:2 LCD screen which is continuously monitor the status of the project, and 230 volts AC input to this transformer which is stepped down the 230 volts AC to 12 volts of AC, and that will be converted into 12 volts of DC as well as 5 volts of DC in the stages like rectification to convert AC to pulsating DC, filtration to remove the pulses and to make the pure DC voltage, and that pure DC of 12 volts is input to the battery pack through this electromagnetic relay, that is the charging voltage. And operating voltage of our microcontroller is 5 volt. For that purpose, we kept a 7805 voltage regulator which will take 12 volts DC input and provide us the 5 volts DC output. Once we provide the 5 volts DC output, it start reading input from the voltage sensor and temperature sensor. Whenever the abnormality detected, temperature on the buzzer, and the low voltage detected, the relay will switch it on along with this buzzer. So these are the major components and the flow of the project. Let us check with the demonstration. Yes, we on the power supply to the kit. A welcome message displayed on the LCD screen. We can see that, and later on here we can see the BP nothing but battery pack voltage, and 25 DE nothing but degree centigrade, and SOC SOH state of health and state of charging. So after around a certain duration, these values will be calculated, as you can see that. Okay, and now so let us increase the temperature. So we are using the external heating to increase the temperature. So when the temperature crosses the threshold value of 45 degrees centigrade, then the system will provide us an audible alert through the buzzer as well as a visual alert in the LCD display. So here this is the main thermistor temperature monitoring component, this black color one. And the next, whenever the voltage is low, means we are isolating the voltage to the voltage sensor. Whenever the voltage is less than 8.5 volt, then automatically the relay will get switched on as indication of battery is charging now. And whenever the voltage is above 13 volts, then the sufficient voltage as noted and the relay will be off. So here what we are doing is we are reducing the voltage by manually disconnecting the voltage to the voltage sensor. Means there is no voltage, whether it is a 0 or 1 or 7 till 8.5, it is low voltage, and whenever it is above 13 volts, then it is a normal voltage and the relay will switch it off. Thank you.